What is Europa Clipper, and why did NASA spend $5 billion and 10 years to make it?
NASA Europa Clipper, one of the most exciting space missions of this decade. The mission will explore one of Jupiter's most mysterious moon, Europa, to find out if its icy oceans can support life. We'll talk about how it will conduct tests, its instruments, and how it will communicate with Earth.
Let's start with the basics. Europa is one of Jupiter's 79 moons and has fascinated scientists for decades. Why? Because underneath its thick layer of ice, Europa is believed to have a vast ocean, possibly containing more water than all of Earth's ocean combined. This makes Europa one of the most exciting places to search for life in our solar system. Scientists believe that this ocean, combined with the heat of Europa's core, could create an environment where life might exist. But how do we actually study a moon that's over 400 million miles away? That's where Europa Clipper comes in.
The Europa Clipper is designed by NASA to orbit Jupiter and make close flybys of Europa. Over the course of several years, it will collect detailed data without ever landing on the moon.
With its massive solar array and radar antennas, Europa is the largest spacecraft NASA has ever developed for a planetary mission. The spacecraft has large solar arrays as it operates in the Jupiter system, which is more than 5 times as far from the Sun as Earth. The spacecraft is about 16 feet in height. With its solar arrays deployed, the spacecraft spans more than 100 feet. Europa Clipper is not a life detection mission. Its main science goal is to determine whether there are places below Europa's surface that could support life. During the mission, the spacecraft will perform approximately 50 flybys of Europa.
You may be asking, why flybys?
Clipper's orbit around Jupiter is preferred due to the belts of intense radiation that surround the planet, which could damage electronics. Initial mission concept studies showed that a spacecraft orbiting Europa might only be able to survive for a few months, while a Jupiter orbiting mission should have a multi-year lifetime. Clipper's trajectory allows for about 50 flybys of Europa, each with a different close approach location, to allow almost the complete moon to be mapped in high resolution. After each close approach, the spacecraft will travel outside of Jupiter's radiation belts to download data, upload new commands, and prepare for the next flyby.
So how will Clipper collect samples from a moon covered in thick ice? Great questions. It will rely on some clever techniques with its close flybys.
These tools are not just collecting raw data, they work in sync, providing complementary information about Europa's surface, atmosphere, and internal structure. Let's take a closer look at these instruments and what they'll accomplish.
The first tool is called REASON, which stands for Radar for Europa Assessment and Sounding, Ocean to Near Surface. This is Clipper's ice-penetrating radar, which is one of the most crucial instruments on the spacecraft.
REASON will send radar waves down through Europa's ice to map out their layers beneath. Scientists want to figure out how thick the ice is and whether there are leaks or water channels across the surface. Think of it like using X-ray vision to see through the ice and reveal what's happening deep below.
Next up, let's talk about how Clipper will map Europa's surface. First, there's the Europa imaging system, which is basically Clipper's camera. It will take high-resolution images of Europa's surface, showing us any cracks, ridges, or any other strange features that might hint at an interaction between the ocean and the ice.
By studying these surface features, scientists can look for places where the ice might be thin or where material from the ocean could be rising to the surface. Then there's the MISE, Mapping Image Spectrometer for Europa. This powerful tool will map Europa's surface in great detail, analyzing infrared light reflected from Europa. It will measure the presence, absence, strength, and the weaknesses of various wavelengths or frequencies of light. It can detect things like salts or organic molecules that might come from the ocean below, which could give us clues about the habitability of Europa.
Now, one of the most exciting possibilities is that Europa has water vapor plumes erupting from beneath its icy surface. Clipper has 2 instruments designed specifically to fly through these plumes and collect data.
First, we have the SUDA, Surface Dust Analyzer. This tool will analyze tiny particles of dust or ice that come from these plumes. By studying these particles, scientists can learn more about the composition of Europa's surface and maybe its oceans. And then there's MASSPEC, which stands for Mass Spectrometry for Planetary Exploration. Mass spec will strip electrons from incoming gas molecules, making the gas molecules into positively charged ions, which will answer which gases are from Europa. This will tell us the chemistry of Europa's surface, atmosphere, and suspected ocean. Mass spec will also study how Jupiter's radiation alters Europa's surface compounds, and how the surface and ocean exchange material.
Europa doesn't just have an icy surface and a hidden ocean, it also has a thin atmosphere. And Clipper has a few tools designed to study this atmosphere and its interaction with Jupiter's magnetic field.
First, there's PIMS, the plasma instrument for magnetic sounding. PIMS will measure how Europa's atmosphere and subsurface ocean interact with Jupiter's powerful magnetic field. By studying these interactions, scientists can learn a lot about Europa's subsurface ocean. Next up is the EUVS, the Europa Ultraviolet Light Spectrograph. This instrument will look at ultraviolet light reflected from Europa to study the composition of its atmosphere and any plumes of material. Just like a prism can separate visible light into a rainbow light projection of colors or wavelengths, scientists can do the same for ultraviolet light and analyze images of that light to identify what the substances are made of. Finally, there's ETHIMIS, the Europa Thermal Emission Imaging System. This instrument will measure heat emitting from Europa's surface. ETHIMIS can detect warmer regions where the ice may be thinner or where the ocean might be interacting with the surface.
So how does all this precious data get back to Earth? Well, Clipper will communicate with Earth using a high-gain antenna, which allows it to send information hundreds of millions of miles. The data will be beamed back to NASA's Deep Space Network, which uses massive antennas located in places like California, Spain, and Australia.
However, this communication isn't instant. Because of the distance between Earth and Europa, it can take up to 45 minutes for signals to travel each way.
You may be wondering, will Clipper bring back samples to Earth? Unfortunately, the answer is no. But future missions, possibly involving a lander, could be designed to collect and return samples to Earth.
So why was Europa Clipper developed? NASA decided to develop Europa Clipper because of its tantalizing evidence from past missions like Voyager and Galileo. These missions hinted that Europa has a subsurface ocean, but the technology wasn't available to study it in detail until now.
In 2015, NASA greenlit the Europa Clipper project, recognizing the moon's potential to teach us about the possibility of life beyond Earth. After its launch, scheduled for October 2024, it will take about 6 years for it to reach Jupiter, arriving around 2030. Once there, the spacecraft will orbit Jupiter for several years and perform 50 flybys of Europa.
Each of these flybys will bring the Clipper closer to Europa's surface, gathering data on the moon's ice, atmosphere, and ocean. The mission is expected to last through the 2030s, but it could be extended depending on its success. Imagine what we could discover if Europa's ocean contains the right ingredients, liquid water, heat, and the right chemical compounds. We could just find evidence of microbacterial life. Even if we don't, the data will teach us more about how moons like Europa and other icy worlds in the universe are formed. This mission could give us our first real insights into whether life exists elsewhere in our solar system, making it one of the most exciting space missions ever launched.
What do you think? Will we find signs of life on Europa? Let us know your thoughts in the comments below. Thanks for watching, and as always, keep looking up.